Okay. Hello everyone. So the today I will take one topic on the ICS subject, instrumentation and control system. Subject is the I will discuss today this topic. Already in the classroom, the relation between resistance of material and temperatures already several times I have discussed. But today, why again this topic is here I need to derive some mathematical expressions between the resistance of the material and the temperatures. What we know about this concept, sir, whenever the temperature changes, right? Whenever the temperature changes, then the resistance of a material also changes. That means in the universe, in the nature, such kind of materials are available which are very much sensitive to temperatures. Once the temperature will be changed, what will be happen to the material? The resistance of the material immediately will be changes. So this concept, this principle we are using for measurement of temperature. I mean, once the resistance will be changes, that change in resistance can be a measure of temperatures by suitable arrangement. By supplying the signal to a Houston circuit, I can able to measure what is the temperature right now or what is the temperature of a particular place based on based on the resistance changes to the material, right? This is theoretical concept, sir. Which instrument is working on this principle? When temperature changes, resistance changes. Later the change in resistance can be a measure of temperature. Which instrument is working? So resistance thermometer, right? Resistance temperature detector, resistance thermometer is working on this principle. Sir, suppose you assume here, now I'm going to derive the mathematical expressions. Why? Because later I will tell why the mathematical expression is required. Just observe what is the mathematical expressions here between the resistance of material and the temperature. It's very interesting. Observe here. Sir, suppose this is a material, platinum material. You assume platinum is used generally. We are using this platinum for a material for I mean resistance temperature detector, resistance thermometers, right? So suppose this is a material, platinum materials. Now the temperature of the material is mm, T naught. Temperature of the material is T naught. So while the temperature is T naught, that time let the resistance is R naught, right? So temperature T naught, that means normal condition, normal atmospheric condition, temperature is T naught. Reference temperature, you can assume it, normal atmospheric temperature is reference temperature. Let the temperature is T naught, and the meanwhile the resistance of the material is R naught, right? Now this is my first case. Now come to the second case, sir. Now the same material, right? Same material is here, same material is here, but this time some temperature changes. Okay, this time some temperature changes. Okay. This time some temperature changes to the material because of sunlight, right? So because of this sunlight, some temperature of the material is changes here, right? Sir, observe slowly. So this is okay. So because of the sunlight, the same material which was having temperature T naught, reference temperature, I mean normal atmospheric temperature. Now at a moment, because of the heat from sunlight, the temperature changes to from T naught to assume T1. Sir, if the temperature is changing here, T naught to T1, right? T naught to T1. Sir, can the resistance of the material will be changed or not change? Obviously, resistance of the material will be changes because there is a relation. If temperature of the material will be changes, then automatically resistance of the material will be changes. Sir, increase or decrease? It will be increases. No, several times I have told also about this. Sir, let the resistance become R1. Sir, here R1 is greater than R naught, right? Greater than R naught, greater than R naught. Sir, then what? How much value increases here? If the initial condition the value was R naught, right? If the initial condition the value was R naught, when the temperature is T naught, now temperature become T1. Temperature become T1. Then what is the resistance changes here, sir? Observe here, sir. Sir, what is the equal R1 equal to? I can write R1 equal to. Sir, what is the initial resistance? Sir, R naught. When the temperature was T naught, the resistance was R naught. Now temperature become T1. Sir, what is the resistance will be here become here, sir? R1. What will be the R1 value? Sir, R1 value become R naught plus R naught into alpha. So here alpha symbol is not there in the keyboard. So I'm writing alpha. Alpha into delta T. So delta T here nothing but T1 minus T naught. Right? T1 minus T naught. Observe this equation. Sir, when the temperature is T naught, that time resistance was R naught. Right? Resistance was R naught. Now temperature because of this sunlight heavy temperature, the temperature changes from T naught to T1. Temperature changes from T naught to T1. So because of this temperature changes from T naught to T1, there is also resistance will be changes from R naught to R1. Sir, what is this R1 value now? Right now, the R1 value, but what is the initial value, sir? R naught, right? The initial value is R naught. Now, because of this temperature changes, this much resistance increases. What is the R naught into alpha into T1 my delta T temperature? Sir, what is this alpha? Observe here. Sir, what is this alpha here, right? What is the alpha here? Alpha is called as temperature coefficient. Temperature coefficient, right? Or thermal coefficient, we can say temperature coefficient or thermal coefficient. Sir, what is that? It is denoted by this symbol. Which symbol, sir? Alpha symbol. Here alpha symbol is not available in the keyboard, so I'm writing the alpha in a word, right? But while you write, you give symbol alpha. You know what is the symbol of alpha, right? Temperature coefficient, or it is called as alpha. Sir, what is the temperature coefficient? Okay, what do you mean by temperature coefficients? Okay, I will tell. Observe here, sir. Suppose here is a material is there, one metal is there, metal piece is there. Now the metal piece temperature right now it is 40 degree, was 40 degree, right? 40 degree. And while the temperature is 40 degree, the resistance of the material, suppose you assume at 0.08 ohm, right? 0.08 ohm. The resistance of the material is 0.08 ohm. So how to calculate the resistance? Sir, very simple. Okay, how to calculate the resistance? Sir, very simple. What you will do? Sir, connect here. You connect the wires. Right here, you connect the wires. Uh, battery supply you give. Battery supply you give. Right, like this. Oh, like this you connect. Right, control Z. Observe. Hmm. Hmm. Okay, I'll connect. Sir, how much voltage, sir, here? Sir, I'm giving how much voltage? Sir, V naught. V naught voltage I'm giving. Generally 230 volt we are supplying, right? 230 volt. Right. Sir, once V naught will be supplied, you can measure the current here. Here you can measure the current. This is the material. When the current will be pass through these materials, because of this resistance, there will be a drop in voltage. You can measure voltage this side, and voltage you can measure voltage in this side, or you can measure voltage this side, right? There is a drop in voltage because of the resistance of the materials. So what will be happen? By the help of voltmeter device is there, ammeter device is there, I can measure the voltage and current. I can measure the voltage and current V and I. Once I will get the V and I value, I know the relation. Ohm's law, V equal to, okay, IR. V equal to IR. Okay, so from the relation, I can calculate the R value. So in this way, I can calculate the R value. Okay, that is not so important in here, but here assume that, observe, sir, here a material is there. The temperature of the material is how much, sir? 40 degree. Can you measure the temperature? Thermometer is there. By the help of thermometer, we can measure the temperature, right? So temperature is 40 degree, and at this moment, the resistance of the material, you assume that 0.08 ohm. 0.08 ohm. Now see, what is the second case, sir? Same material, okay, same material. What I have done exactly, I increase the temperature 40 to 41 degree. Only 1 degree I raised. 1 degree I temperature raised. Then what will be happen, sir? Definitely, for this 1 degree rise, this resistance value also changes, right? The resistance value also changes. Let the resistance changes to 0.084. Sir, earlier it was 0.08. Now due to this 1 degree, the resistance changes to 0.084. Sir, for this, sir, how much temperature difference is here? Only 1 degree. Sir, for this 1 degree temperature difference, right? For this 1 degree, only 1 degree temperature difference, 1 degree temperature difference, how much resistance are changes here? So resistance changes nothing but 0.084 minus 0.8, right? What value I will get, sir? Equal to 0.004. This value is nothing but called as temperature coefficient, right? This value, this value will be called as temperature coefficient. Which value, sir? 0.004, right? Sir, what is the definition of temperature coefficient then? Okay, the definition is very simple here. From this diagram also you can write your own definition. Sir, temperature coefficient is defined as, sir, relative change in a resistance per unit degree change in a temperature. Okay, relative change in a resistance per unit degree change in a temperature, unit degree Celsius change in temperature, or unit temperature difference is nothing but called as temperature coefficient. Okay, now, sir, what I have done exactly? I have taken a metal. temperature 40 degree, 40 D for degree here. Degree symbol also not here coming in this paint software. So I have written degree, I have written degree here. So at this moment resistance is 0.08. Let only 1 degree temperature I allowed to rise here, 40 to 41. For this 1 degree rise, what is the temp resistance changes here? 0.084. So for this 1 degree temperature difference, how much resistance changes? Final value minus initial value 0.004, right? 0.004. That means for this 1 degree temperature difference, how much resistance changes are 0.004. This is nothing but called as temperature coefficient, right? Temperature coefficient. Sir, if further temperature become 42 degree, then how much temperature will be changes, sir? Sir, how much resistance will be changes? 0.004 into 2 for 43 degree into 3 for 44 degree. That means for every 1 degree change in temperature, there is a change in resistance value. How much? 0.004. Nothing but temperature coefficient. Sir, what is the definition of temperature coefficient? Temperature coefficient is defined as the relative change in resistance per unit difference in unit degree difference in temperature. Very simple definition here. So come to here. This is different thing. Okay, this is different thing, but my intention is what to discuss this one only. Observe here, sir. Here, so here alpha r naught alpha into t1 minus t naught. This much resistance is changed, sir. What is the initial temperature? T naught is the initial temperature, right? Reference temperature we can assume atmospheric temperature. During that time the resistance of the material is r naught. Resistance of the material is r naught. Now because of this heat from sunlight, what happened here? The temperature changes from t naught to t1. So if resistance changes T naught to T1, right? T naught to T1, then how much, sorry, if temperature changes T naught to T1, then how much resistance will be changed? So resistance will be changed R naught to R1. What is that R1 value? Sir, R1 value is R naught plus R naught into alpha T1 minus T2. What is alpha? Temperature coefficient. Just before I told about this one, right? Sir, now consider the third case. Second case is over. Now consider the third case. Sir, this is my material, same materials. Oh, red color. Okay, no problem. Same materials. Now this time, temperature, the sun, right? The sun, suppose. Sun is little bit closer. Okay, little bit closer to little bit closer to the material, right? If little bit closer to the material, that means there is rise in temperature is more or not? Yes. Now this time the temperature is T2. Oh, temperature is T2, right? So if temperature is T2, then definitely the resistance will be again changes or not? So resistance suppose R2. Sir, what is R2 value? Sir, what is the article? Sir, what is the initial resistance value when there is no effect of temperature, normal atmospheric conditions? What is the resistance value, sir? Sir, resistance value is what? Resistance value is R not only, right? R not only. Now because of heavy hot sun, so because of closeness of the material to the sun, now what happened? The temperature changes T1, T naught to T2, more temperature this time comparison to T1. The resistance obviously it will change more. And what will be the values? Observe here. I can write the same equation. Sir, R naught plus R naught into, right? Again alpha comes, alpha temperature coefficient into, sir, temperature difference. What is the temperature difference, sir, here? Temperature difference is what? T2, T2 minus T naught. T2 minus T naught, right? Say, okay, T2 minus T naught here, right? Right, observe this two equation, r1 equal to r naught plus r naught plus r naught alpha into t1 minus t naught, nothing but 10 change in temperature. Here also same formula, but different situation I have taken here. First case less temperature rise, second case more temperature rise. Now I want to derive the relation between, what is this relation between r1 and r2? What will be the relation between R1 and R2, or what is the relation between this T1 and T2? Okay, this is T1 and this T2. Observe, sir, how to derive this relation. Very simple. I got the R1 value, I got the R2 value, right? Now I'm going to derive what is the relation between this T1 and T2 or R1 and R2. Observe, sir. Observe here. God. Observe. Sir, what is the R2 value I got? Sir, R2 value you got, R2 equal to R naught plus R naught, right? R naught plus R naught into alpha into T2 minus T naught, right? T2 minus T naught. Sir, what is the R1 value you got? Sir, R1 value I got, R1 equal to, sir, red color means more hot, black color less hot. Like this I have taken, right? R naught plus 1 plus only, right? Uh, R naught into alpha into T1 minus T1 minus T naught, right? T1 minus T naught. Sir, I want to derive the relation between R1 and R2 or T1 and T2. Observe how to derive the relations. Very simple. What I will do? Simply, I will do subtraction here. Okay, subtraction. So if it is subtraction, then what happen? Here plus, it become minus. Here plus, it become also minus. Here plus, it becomes minus. Here plus also, where here minus, right? Okay, observe. Here become plus, right? Sir, what is the answer? Answer I will get, sir, I will get answer, uh, R2 minus R1 equal to, sir, this see, positive plus R naught and minus R naught get cancelled, right? Here R naught alpha and R naught alpha same. I can take a common. If I will take a common here, what value I will get? Sir, R naught into alpha. Symbol is not there. That's why I'm writing in word alpha. Alpha. You have to write the symbol only. Observe, alpha into, uh, here also I forgot to write. Okay, so here also my plus, here it will come minus, right? It will come minus, right? It will come minus. And one more thing, here also minus T naught and plus T naught get cancelled. Then what is the remaining results are here? The remaining result is what? T2 minus T1, right? T2 minus T1, right? Sir, if I'll simplify this one further, what I will be get, sir? Sir, T2 minus T1 equal to R2 minus, okay, bracket, right? R2 minus R1, right? Divided by R naught into alpha, right? R naught into alpha. This is the relation I will get. Next step, if I'll solve again, simplify it, Sir, T2 equal to how much? T2 equal to, sir, T1 plus R2 minus R1. Oh, sorry. R2 minus R1 divided by, right, R naught into alpha. So this is the relation between, right? This is the relation between what? Temperature T2 and T1, right? T2 and T1. Sir, why this derivation? Why this derivation? You have to remember this two formula. R T2 equal to T1 plus R2 minus R1 divided by R naught into alpha. Observe, sir. Why this derivation means? Observe. I will solve one question here. This question. Read this question. A platinum resistance, right? A platinum resistance. mm, a platinum resistance thermometer has resistance how much? 140 and 100 ohm at 100 and 0 degree, right? At 100 degree and 0 degree, the resistance value is what? So one is 140, another is 100. Okay. If the resistance increases 305 when it contact with hot gas. Okay, hot gas means we are heating the materials, right? Determine the temperature of the gas. Determine the temperature of the gas, right? So resistance increases means here definitely temperature become more. So when 0 degree, resistance 100 ohm. When 100 degree, resistance 140 ohm. Now resistance 305. What is the temperature you need to calculate? Sir, what is we need, what given to assume? Take temperature coefficient of platinum is how much? 0.0039 degrees Celsius. That means alpha value is given here. Alpha value. Can I write this one T naught reference value? Sorry, R naught, right? R naught resistance value. R naught. This one is R naught. This one is R1. This value is R1, right? And this value 305. 305 is what? R2. 305 is R2. Sir, this is T naught. Which one? 0 degree is the T naught. And this one is what? T1. This one is T1. Sir, I need to find what is the value of T2. What is the value of T2? And this value is given alpha. This value is given alpha. Right? Can you solve it? Very simple. R1 is given, R naught is given, R1 is given, R naught is given, R2 is also given, T1, T1, T naught is given, alpha is given. Observe the formula. Sir, R1 given, R2 given, right? Why this one came here? Come here. R1 given, R2 given, T1 given 140. T1 given 140 or not? T1. See, T1, sorry, T1 given 100. T1 given 100. R1 given 140. Right? R1 given 140. R2 given 305. Okay, 305. Alpha given 0.0039. What is asked, sir? Find it T2. Can you find it or not? Very simple. This relation will be used to solve this problem. That's why I derived the expressions for you, because there is a chance maybe they will ask problematic questions here, problems and problem. So you should prepare, right? This question answer is there in this expression, in this derivation. This question answer is there. I hope this concept is clear to all of you. Practice this question. uh, I'll solve one, two more question also in the next video. I'll solve and I will share. Right. Okay. I will conclude now, right now. Okay. Take care.